boys and girls. Welcome to session 2 of the continuous series that we are handling mathematics for class 7 and 8. These are the candidates and the pre-candidates who are preparing for the end of year exam. Welcome. Today I want us to handle the topic volume. What is volume? Volume is that particular space, regardless of the shape itself, the space occupied by any object. Could it be amorphous, that's shapeless, or regular shape? The space occupied by that particular object is what we call volume. Now, allow me to take you back to the nursery school, the kindergarten, where you started the shapes that you learned on the first day in a mathematics class. It was a triangle, a square, a rectangle, and a circle. Others came on thereafter. So I want us to start from there, from these basic shapes, so that we can form, we give it a 3-dimension, or we give it some depth and create some shapes. So welcome and walk with us through this world of fun, world of mathematics. Karibu. So the first shape I want us to look at is the square. I want you to remind you about that particular shape, that particular nursery school teacher who taught you about that particular shape. We call it a square. Now, a square, if you have a square and you give it a uniform depth of the same length, you will end up with a shape we are calling the cube. So from the square, we get the cube. The next shape we looked at was the rectangle. Rectangle. From the rectangle, if you give it a little bit of some depth, you'll end up with a cuboid. The other shape was the circle. And that was it. Now, if you give a circle some depth, you end up with a cylinder. So for today, I just want us to zero in on the square, the rectangle, and the circle, which is giving us the cube, the cuboid, and the cylinder, and we are looking for their volumes. Volume. As long as you know how to get the areas of the original shapes, as long as you know how to get the area of a circle, as long as you know how to get the area of a rectangle, as long as you know how to get the area of a circle, then getting the volume of that particular shape is very easy. So volume is equals to the area of the cross section. Area of the cross section, and then multiply that by the uniform length or height. Length or height. So once you know how to get the area of the cross section, I'll just multiply by the given length or what we added to get that particular shape. So here, let's take for example this particular square of side 3 centimeters by 3 centimeters, and you've given it a depth or a height of 3 centimeters. So 3 centimeters by 3 centimeters by 3 centimeters. To get the volume of that particular first shape, we are calling the cube of dimension 3 by 3 by 3. Then we shall say area of the cross section. Area of the cross section will be 3 times 3. That is the area of a square. 3 times 3. So we shall say 3 times 3. This will form the area of the cross section times what is the length or the height of this particular cube. In our case, the cube, the depth is also 3, so I'll multiply by 3. So case study number 1, 3 times 3, the base area, that's 9 centimeters square, times the height of 3 centimeters. Centimeters squared times centimeters. That will be now 9 times 3 to give us 27. Now centimeters squared times centimeters will give me cubic centimeters. So the final answer will be 27, whose units will be centimeters cubed. That is for number 1. The cube. Base area times the length or the uniform height. Now, let's look at case study number 2, which is now a rectangular shape that will give us the cuboid. Now, in this case here, let's give this one 12 centimeters and the width of, let's say, 6 centimeters. Now, giving us this particular shape here, the base will now be 12 centimeters by 6 centimeters, and let's give it a height of just 2 centimeters. Now, in this case, we shall be able to get the base area, the one I'm shading off. So that will be the area of the cross section. So, number B, the cuboid. The cuboid, volume of this particular cuboid will also be the area of the cross section, that is 12 times 6 to give us 12 centimeters times 6 centimeters. This is the area of the cross section times the uniform depth or height of that particular cuboid, which is 2 centimeters. So we say 12 times 6 should give us 72 centimeters squared multiplied by the depth of 2 centimeters, so that I have 4 and 14. That will give us 144 centimeters squared times centimeters will give us cubic centimeters. So remember, in some exams, they just cheat you or challenge you by giving you centimeters or centimeters squared. But remember, volume, the unit should be centimeters squared cube or meter cube, and as long as you know the units you're multiplying all along. Those are 2 examples. Let's come to the last example here, that is the circle, which is circular in shape, which gave us the cylinder. So let's go to number part 3, which will be now, remember this particular circle here. As long as you get the area of the circle, we say the area of the circle, a reminder, pi r squared. Now, in this case, our circular shape here, our cylinder, I'll use this radius of 7 centimeters and a height of 20 centimeters. And they want us to give them the volume of this cylindrical shape. That is the space occupied by this cylindrical shape. Volume, again we say, is equal to area of the cross section, and you'll multiply by the depth of that particular cylinder or the height. So in this case, it will be, what is the area of the cross section? What's the shape of the cross section? A circle. Radius 7. Area pi r squared, which will be pi 22/7 times radius 7 times 7. Now this one gives me the area in centimeters squared multiplied by the height of the cylinder, which is 20 centimeters. So let's move with it. Easy work, a lot of fun. 7 cancel 7. 22 times 7 gives me 154 centimeters squared times the height of 20 centimeters. Now, here we go. I'm multiplying 154 centimeters squared times 20 centimeters to give me the answer in cubic centimeters. That will give me 8, 0, 2 is 3, and 0 centimeters cubed. So there we are. Area of the cross section times the depth. will give me the volume. So we have cleared area of a square, x times x, area of a rectangle, length times width, area of a circle, pi r squared. Give it depth, height of 3, 3 times 3, cross section times 3 to give us the volume. Area 12 by 6, area of the cross section times the depth of 2 to get the volume. A circular shape with radius 7, area of the base. The base and the top are the same, circular, that is pi r squared times the depth of 20. You should be able to get the volume of that particular cylinder. Now, why not also, because we still have a few minutes to go, why not also add the other shape that you learned? That was the triangle, either that particular triangle or right angle triangular shape or isosceles or equilateral, whichever way. Now, if you give it some depth also, you'll end up, let's use this one here, a right angle triangular shape, and give it some depth, and you'll have that particular one created. So once again, just get the area of the cross section, area of a triangle, a half times the base times the height. This one gives me the area of the cross section. If I get the length of this particular prism, triangular prism, I'll be able to get the volume. Now, in our case here, let's now fill it in with some units so that we get it right. So, I'll make the base to be 6 centimeters and the height to be 8 centimeters. Of course, this one you'll tell me it's 10, that will be 10, that will be 8, and that will be 6. Now, how long? The length of our prism is 16 centimeters. How much space does it occupy? Volume. How much space or what's the volume? Will be the area of the cross section, which will be a half. What is the base? 6 centimeters. What's the height? 8 centimeters. And what is the full length? 16 centimeters. So getting the area of the cross section, I'll cancel this one and that one to give me 4. 4 times 6 will give me 24 area centimeters squared times the 16 centimeters. So that now I can get the volume of this particular shape. Let's do the multiplication. 24 times 16, 29. That is 24 carry 2, 12 is 14. Line number 2, 1 times 4 is 4, 1 times 2 is 2. Addition, 4, 8, and 3. So, what we say, 384, the units, cubic centimeters. So, friends, what you just need to know is the area of the original shape. And then you'll be able to use it to get the volume of a given shape. So, just follow that. Is it a cross section? Is it a circle? Pi r squared for the cylinder. Is it a square? Length times length, which is a cube. Is it a rectangle? Length times width times the depth to give us the volume. Or is it triangular? Definitely, it will be a half, the base, times the height. Boys and girls, learning maths is fun. Can you discover more and more? Join me again in the next topic when we are handling another interesting topic in this series. During this holiday, we enjoy ourselves and make sure that we don't rest, lest we rust. Thank you and welcome again. IMBUSI Fanuel saying bye for now. Karibu tena.